My name's Tom Waters. I am a planetary scientist here at the Smithsonian's Center for Earth and Planetary Studies at the National Air and Space Museum. I am also a member of the science team of the Lunar Reconnaissance Orbiter Camera. Using these Lunar Reconnaissance Orbiter Camera images, we have now found many Lobate Scarps that we did not know previously existed on the moon. This is an example of one of those scarps. It's called Gregory Scarp, and it is this feature that's running down through the image here and pointed to by the arrows. Lobate Scarps like Gregory are formed when crustal materials are pushed together to form what's called a thrust fault, and that's illustrated in this diagram up here. Crustal materials are actually pushed together and then break, forming a scarp. Again, just like the Gregory Scarp here. Well, using the LROC images, we've now discovered many new, previously undetected Lobate Scarps. Those are shown in this diagram of the moon by these white dots. The black dots are actually Lobate Scarps that we knew about from the Apollo era. And what's really exciting about this is that, as you can see, many of these newly discovered scarps are sitting at high latitudes outside the area that was actually imaged by the Apollo era photography. And what that means, and including the fact that we now have some of these Lobate Scarps even near the poles of the moon, is that these scarps are globally distributed. Well, why is that important? It means that those forces, the contraction that formed these Lobate Scarps, was a global process. It occurred everywhere on the moon. Well, what would have done that? Well, the moon is basically like every other object in the solar system. It started off hot and it's cooled. Cooling of the interior has actually caused that interior to contract. As it cools, it contracts, and as it contracts, the entire planet, in this case the moon, must shrink to accommodate that change in the interior of the moon. And that is what's caused those forces that have resulted in the Lobate Scarp thrust faults. What it tells us about the moon is that the moon is still potentially active. In fact, we know the moon is still active from the Apollo era, when we had seismic stations on the moon that actually operated and told us there were moonquakes. And those moonquakes mean that the interior of the moon is still active. There are things going on. The moon is still cooling. At the very least, the moon is still cooling, and that's causing, again, the moon to contract. Now, one of the really interesting questions is, are any of these moonquakes that were recorded during the Apollo era actually connected with any of these Lobate Scarp thrust faults? And that's a question we'll be looking at in the future.